All right, good morning or afternoon, gentlemen, ladies and gentlemen. So again, I'm sorry that I have to be gone again today. I know I've missed a lot of time this semester. It can't be helped. So it is what it is. So I'm going to ask you to do what I've always asked you to do. Just work hard, think about this stuff, take the notes, do the work I'm asking you to do. And then when we come back on, what's going to be Friday, I'll try to help you kind of tie these ideas together as we move forward into this new unit, which is going to kind of be the last unit before the semester, which is actually pretty quickly coming up on us. And so the thing we're dealing with today, this is Unit 3, the first day of Unit 3. We have to talk about triangle congruency. And so the big question is, and as you maybe pause the video and get these questions down, hopefully these notes will help you answer this big question: how do you prove or show two triangles are congruent without translations, reflections, and notations? And so basically up to this point, we've had this triangle, and we moved it by sliding, flipping, by turning, by reflection, translations, or rotations, so it ends up in some other location. Well, if you think about this question here, like how do they actually show that these triangles were congruent? Well, it has a lot to do with the nature of these transformations. These transformations, the translations, reflections, and rotations, they are by definition what we call rigid. Now, rigid has a very simple and straightforward definition. So what rigid transformations do is they move a shape without actually changing it. And so if you kind of notice, I'm covering some of the blanks that you have in your notes. Make sure you guys are catching up with that. Again, pause, rewind if you need to. And so like a good way to think about translations, reflections, and rotations is that they're kind of like a vehicle. And so like you get into a vehicle, the vehicle takes you somewhere, but you don't change after you get out of the vehicle. It's simply a transportation device that moves you from point A to point B. Well, that's what these are too. The translations, reflections, rotations, because they're rigid transformations, they just kind of move the triangle to a different location. And so as long as we knew that you moved by one of these motions, we could trust that the triangles would end up being congruent. So just a way of demonstrating, and maybe a little bit of a review, we have these triangles here. So this one on the left and one on the right here. Let's say I wanted to map like a reflection. Well, we know that a reflection like requires a line of reflection. And as long as we knew that we have these perpendicular bisectors, in other words, like this red line, let's change up a little color here, and then like this blue line, and then like this green line, as long as we knew that the pink line perpendicularly bisected, in other words, cut the red line in half at a 90-degree angle, and cut the blue line in half at a 90-degree angle, and the green line in half at a 90-degree angle, as long as we knew this happened, then we can trust the triangles themselves were going to be congruent. We didn't really have to pay too much attention to the triangles because we knew a reflection happened. The same is true for a translation. So recall that translations move with vectors. These vectors by rule have to be both parallel and congruent. Okay. So parallel and congruent, that mark kind of got away from me, but that's okay. We know that they are moving in the same direction and they're moving the same amount. Okay. And so as long as we knew that like these vectors are parallel and congruent, we knew that the beginning and ending triangle would have to be congruent too. Kind of dropping down to the statement, like this is the logic behind rigid transformations. If a shape was mapped by what we call a rigid motion, and again, rigid motions are just going to be translations, reflections, or rotations. Okay. So we can make a little note here. We're talking about translations, reflections, or rotations. Okay. So logic is, as long as the shape was mapped by rigid motion, that we could assume, and like that's a really powerful word in mathematics. If we could assume it, that the image and pre-image were indeed going to be congruent. In other words, going to be the same exact size and shape. We didn't have to check the triangles as long as we knew we were using those things, those elements. Okay? And which is kind of a perfect setup for what we have to talk about today, because what happens then if we don't know a rigid transformation took place? And so all is well and good if we could map a reflection or map a translation or map a rotation, which I didn't put on here just because those are kind of difficult to draw. And so now what if we take that away? Like we don't actually have a reflection, translation, or rotation that we can map ourselves. How are we going to tell the triangles are still congruent? Now, quick side note, remember if we're talking congruent, we're talking structurally identical. In other words, it's a version in geometry of the idea of sameness, or things that are the same. And so how can we tell these two triangles, listed here on the right, are actually going to be congruent if we can't map a translation, reflection, or rotation? So if we don't have one of those transformations, we instead have to analyze the parts of a triangle, namely the sides, of course, excuse me, and also the angles. Okay, and so in absence of being able to reflect, translate, or rotate, we have to look at the pieces of triangles and ask ourselves a critical question. To do that, we should probably define the full definition of congruency. And when I say the full definition of congruency, again, in geometry, definitions mean something very specific. In this particular case, it's a two-part definition, something we call a conditional statement. So the first part is we have to have all corresponding sides and angles in two triangles congruent. And if we know those things are congruent, then we can conclude the triangles can be congruent too. Now, we have some vocabulary here we need to take care of, namely this idea of corresponding. Okay? So corresponding, I'm going to try to demonstrate below, but the short version of corresponding is that it's just matching. Okay? So matching in two different triangles. That little symbol right here, that's a shorthand for triangle, and so you draw a little triangle, and that's what that means in geometry. So there's lots of definitions for corresponding, but again, it's just like the same location in two different triangles, or matching information in two different triangles. So here's what the definition of congruency means. If I look at this side length RS, and I mark it, say, with one tick mark, what I have to be able to prove in the other triangle is that its matching piece, its counterpart, its matching information in a different triangle is also congruent. Please recall these congruency marks right here. Because they match, I'm showing those two sides are congruent. And now that has to be the same, it has to be congruent for all the sides and all the angles. And so SW has to be congruent to its corresponding part, UV. Again, they're corresponding because they're both kind of on the right-hand side of the triangle. And of course, the bottom RW has to be congruent to the bottom TV. Now notice I'm using different amounts of tick marks for each side because I'm matching them per triangle, and while it doesn't matter how many tick marks I use, they have to match. And so in other words, green matches green, highlighter here, like this purplish matches purplish, and the pink here matches the pink here. And so the sides and the angles have to match. So not only the sides, but we can also say this angle up here, S, matches the one at U, the one at R, and notice I'm using two arcs here, matches the one at T, and I'll triple up this one, the one at W, the angle at W matches the angle at V. Okay? And that's what it means to be corresponding. It just has to kind of be matching two different triangles. Now we should probably do one step better. We can write something called a congruency statement. Okay. And a congruency statement it's usually in two parts. There's what we call the full congruency statement and then the partial. The full congruency statement would list out all the parts that are congruent and then make a statement about the triangles. Let's do that first. Now what I mean is this. If we take angle S, there it goes, angle S in the first triangle on the left, we can say that it matches, is congruent. We'll call it this, that's a symbol for congruency, to angle U in the right-hand triangle. They both have one mark, they're both up top here. So this angle S has to match this angle U. Okay. So we can say that angle R, which is on the bottom left of the first triangle, is congruent and corresponding to angle T. And of course, angle W is corresponding congruent to angle V. And again, we're just matching the corresponding pieces. And so the angle at R matches the angle at T, and the angle at W matches the angle at V. And I'm just making a statement. Now, congruency statements are more of a record of what's going on than anything. Okay? Now we should also deal with the side lengths. So we can't just say name angles, we should think about side lengths. And so we have the two corresponding sides, and we have to use geometric notation here. So we have the side length RS as a segment, congruent to TU. We have the side SW matching with UV. So we make that SW matches with UV. Okay, and of course, last but not least, we have the bottom RW and TV. So RW and TV. Okay? And so this is what it means to be the full definition of congruency. This guy right here. So to prove these triangles are congruent, if we don't have a translation, rotation, or translation or reflection to fall back on to show that it's moved by a rigid transformation, we have to show that all the information in both triangles are congruent in order to claim the triangles themselves are congruent. And so we have to make a list of all the pieces. We have to be sure all 6 pieces match. And then we can make a general statement of congruency, which is just by naming the triangles. Now, in this particular case, I know we kind of talked about this a little bit. It doesn't really matter like how you call the first triangle. And so we could call this SWR, which kind of starts at the top and goes clockwise, but it's just as good to call this triangle, say, RWS, or perhaps, sorry about that, or perhaps WSR. What does matter, though, is how you call the second triangle. Now, we don't have to name it 3 times. I'm just trying to demonstrate there's more than one way to call this triangle. But if we call the first one WSR, we have to call the other one VUT. The reason being is that all the pieces have to match part by part. And so if you notice here, W and V correspond. They're in the same location. And so they're both listed first. S corresponds to U. If you look at the S and you look at the U, they're marked the same way. And then that leaves R and T being also matching. And so that's one way you can call these triangles in a congruency statement. And so just as an issue of practice, if we call the first triangle SWR, we must call the second triangle, so SWR, we have to call it UVT. Okay? To get a little practice in, why don't you pause the video for a second before I reveal this answer. Take a guess at if the first triangle is referred to as RWS. Okay? What must you refer to the second triangle as? So pause, write down really quick. Okay? Hopefully you wrote down, it has to be RWS, so this one has to be TVU. Okay? Now again, you don't have to write the triangle's name 3 times, but the point being, if you're going to make a congruency statement, you first have to make sure that all the information, all the corresponding parts, all the corresponding sides and angles match in both triangles and are congruent. And then you have to make one statement about the triangle. And again, it doesn't matter how you write the first one, but the second one has to match. And so these are just options. Okay, so this is like option 1, option 2, and option 3. Okay, and so the evolution so far is maybe take a second, take a beat, and kind of collect where you are. If you have translations, rotations, or reflections, you can ensure the triangle you're moving is indeed congruent. But what happens if you don't know you have a rigid transformation? What are you going to do? Well, you have to now go to the parts of the triangle. You have to ignore like how it's been moved or how it's oriented, and you have to pay attention to the individual parts. Okay? And so as this idea evolves, what happens now is how we have to note it. And so we saw before like some of the congruency pieces and how we're going to have to mark them, but like how we're going to actually mark the triangle. Well, we kind of did this a second ago, so this is going to be more like an exercise. And so use this given information to mark the triangle at the right and then make a congruency statement. And so if you're going to do this a smart way, you should pause the video right now, mark the triangle up, and then resume the video and see if you're actually correct. Okay, so pause the video, use this given information right here to mark the triangles, and then write a congruency statement about those triangles at the bottom in the way we just did. So this is kind of just like practice. So pause the video and do that. Okay, so hopefully this is me welcoming you back after you practice, just to confirm your answer. So let's get to it. So JH and YL had to be congruent, so we have to find JH, and I'll mark it with a single tick mark, and we have to match that with YL. That's going to be on the left. Okay. HA matches with LP, so matches on the bottom. Okay. And then we have JA right here, 1, 2, 3, matches with YP, 1, 2, 3. And it's a kind of a cool consequence of not having to deal with transformations anymore, is that we don't really care that the second triangle is twisted and maybe flipped or rotated or whatever. What we care about are the individual pieces. How are those coming together? Okay? Now we can't stop there. We also need to go ahead and mark these angles. And so we have the angle J matching with the angle Y. So I'm just going to give them one arc each. Again, it doesn't matter how many arcs to give it. I just tend to go in order because that's kind of my style. A and P, so the angle at A. And notice how I'm saying that. I'm not calling it the angle A. I'm calling it the angle at A. Okay? And that's a big distinction because a single letter on the outside doesn't name the angle, but it does identify the location. And then finally, the last one, the angle at H, so I'll give that a triple, has to match the angle at L. Give that a triple. Okay? And so now that's all marked, and hopefully you're making corrections now if you made a mistake, or you're just confirming that you're right. We have to make a congruency statement. Now we don't have to list the individual pieces because they're listed. So we should probably start right here with a triangle. Now on this first one, it doesn't matter how we name this, so just pick any order you want. I will pick JAH, so angle JA, or triangle JA. But we have to match this precisely with the angle on the right. And so in terms of how to match this, so we're starting at J, and so we have to match that with its corresponding part, which is going to be the angle at H. I'm sorry, angle at Y. And so it's going to be Y first. And so the second one, so AH, so A is here. Notice it has two markings, and so it matches the angle at P. And so we'll put P next. Okay, and finally, the angle at H with 3 marks matches the angle with L, so it'll be YPL. And so although this is not the only way you could have named it, that's one of at least a few options. Okay, so again, this is an opportunity for some practice. So pause the video. If the first one went well, this should go equally as well. But go ahead and try it, pause it, and then come back. Okay. So welcome back, hopefully. So let's go ahead and mark this up. So we have AB matching with DF. Okay. We have AZ matching with SF. Okay, if you're wondering why I'm going with 2 marks and 4 marks, I'm going to repeat what I said before. It doesn't matter how many marks you make, it just matters that you're matching. And so BZ is going to match with DS. Let's go to the angles. And so BAZ, now this is a different, remember this is the more formal way to name angles. And so before we're just choosing a single letter and saying, well, the angle that's there. The 3-letter convention isn't that much tougher, it's just a little tougher to read. And so remember, BAZ is the angle that starts at B, runs through A, and ends at Z. And so BAZ is going to be this guy right here. Okay, remember, the letter in the middle is where the vertex is. So DFS starts at D, runs through F, ends at S, and so that's going to be right here. Okay. So ABZ, so it's going to be ABZ, and SDF is going to be this guy right there. Okay. AZB, so 1, 2, 3, of FSD, so FSD, S in the middle, so that's where the angle is going to be. Okay. Making a congruency statement, again, the first one doesn't matter, so I'm just going to go BAZ. Okay, and so we have to mark it with the 1 on the right, so 2 starts with 2, so B corresponds to D. Then it goes up to A, the pink one, so that means we're going to go F, and it ends at a triple Z, so we're going to end at a triple S. Okay, and so we have a triangle BAZ is congruent to triangle DFS. Okay, and so at this juncture, it's probably good to take a little pause. And maybe answer this question. So what are some tips that beginners should know about this process? And so if they're walking to this blind, you already had about 20 minutes into me dribbling on about congruency statements and transformations, and then how to mark and name angles. And so what are things that you should probably know about this process? Off the top of my head, I think the big thing to know is that the congruency statement is just a record. Why is that not writing? Okay. Okay, and what I mean by record is it's really just tracking the information that you know has to be true in order for the triangles to be congruent. The order matters, okay, especially in the congruency statement. So that order right there matters the most. But there are multiple ways you can construct or write a congruency statement. Okay, and feel free, of course, to add your own. These are your notes. That's a suggestion on things beginners should know. And so things that tricked you that hopefully are no longer tricking you from the beginning of this, you can definitely record in that spot. Okay, so we just have one more kind of aspect to study or to look at in terms of like how this works going to play out for you. And so we do have to kind of consider what calculations you're going to have to be responsible for knowing. My claim is that there are basically two varieties, and I think this is all blank for you, so make sure you fill this in. There are two varieties of algebra-based problems when you think about calculations. One is you're going to be given a congruent set of triangles, and then you're going to have to like work some algebra there. The other one is that you're going to have to find values that confirm congruency. Do recall that the definition of congruency, as I kind of scroll back up, the definition of congruency is that all corresponding sides and angles and two triangles have to be congruent. And so if I say like you have to find x's to make that true, you have to find x's and make two things the same. And so the good news is that no matter what variety you're dealing with the same idea. You're dealing with this idea of sameness. And sameness really is just about congruency and equivalence. And so when I talk about equal, what I'm really talking about is an equation. Okay? So when you're dealing with this information, what you're really dealing with is equation writing, and congruency is basically equivalence. And so, let's get into a couple examples, and I'll try to make that a little more clear. So here on the left is our example problem. We're given this triangle. We're told this congruency statement that ADB triangle is congruent to the triangle CBD. So we know everything is congruent. And so right off the bat, we know that all these corresponding pieces have to be congruent too. In terms of steps, I think there are basically four main steps here. The first one is the one I think people tend to gloss over the most, and that's silly because it's actually a really important one. You should identify all the pieces that are corresponding. Don't assume. Actually use your congruency statement and mark the things that you know have to be congruent. Let me explain what I mean. So ADB congruent to CBD. Well, that means angle A, which is listed first, has to be congruent to the angle at C. Now that's not important for this problem, but it's good exercise, and so it's okay to actually mark that up. Switching colors here, we know that the angle at D has to be congruent to the angle at D. Now D is in the same location, but in both triangles in the corresponding parts, what that means is that part of the triangle has to be the same as that part of the triangle. And my guess is you're already kind of seeing how some of this is actually going to play out in terms of how we're going to solve. But let's keep going. Let's see. Okay, so we have the angle at B congruent to the angle at B, and again that's split over two triangles, and so we know that this triangle, or angle right here, is simply congruent to the angle right there. And again, not important for this solving process, but good to note. While we're at it, let's go ahead and mark the sides as well. And so we know the pieces have to line up, and so if I take it two at a time, the side length AD has to be the same as the side length CD. So this guy right here. These have to be congruent as well, so I'll mark them as such. And we can go down the line, and we can kind of continue the thought. We know that DB has to be the same as DB, so the guy in the middle is congruent to the guy in the middle. I'll mark that with a double. And then last piece, we know that AB has to be congruent to CB. So AB, boom, 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 congruent to CB, boom, boom, boom. Okay. So knowing that what pieces match up with which is a very crucial first step. The second step is we have to set up equations based on the matching parts. And so we have to solve for t, and we have two different versions of it, and we're going to go ahead and set up a couple different equations. And so one we're going to set up based on side length, and one we're going to use set up based on angles. And so let's do the side length first. Okay. And so the side length, we know that AD has to be congruent to DC because it's given to us. We're told that off the bat because we know the triangles are. We know the side lengths are. And I'm trying to color coordinate, so AD is like the side length, and then BC is one at the bottom. And so we can do a substitution. AD is actually going to be the 3t plus 1. And we know that's going to be equal because congruency and equal mean the same thing as 4t minus 3. Okay. And so like once we have this equation, we can drop back into like last year's stuff and just solve using algebra. Like once we have this to this moment, we just have to use our good algebra solving techniques and solve this thing. And so we'll probably drop a line here. We know we got to get all the t's to one side, so let's subtract 3t on both sides. Okay, so that's going to give me a plus 1 on the left. 4t take away 3t's is just a single t, and then we have minus 3. Okay, so continuing, we can add 3 to both sides. Okay, so let's cancel, leaving us just with a t, and then of course 1 plus 3 is equal to 4. Okay. So that's definitely the side length part. In terms of the angle part, and really this is where we can incorporate our last step, we should verify our solution. Because they're both t's, we can set up a second equation based on the angle values. And so let's set one up on angles. Okay? But we know the angles, just like the side lengths, have to be congruent. And so if we look at the angle values, we have one as 32, we have another as 2t squared. And so we can set up another equation. We know the angle at D has to be the same as the angle at D for both triangles. In other words, 32 degrees has to be the same as 2t squared. Okay. And now we can just go about our business of solving the algebra. So again, we just pull those numbers because the angles themselves had to be congruent, and so those numbers had to be the same or equivalent. Now in terms of solving, I think division by 2 is probably the first good move. So we have t squared. 32 divided by 2 is going to be 16. Okay. So our next move should be getting rid of the square value, which we can accomplish by square rooting. Okay, so square roots and squares cancel, leaving us just with a t. And square root of 16 is 4, because 4 times itself is, of course, 16. Okay? And so we managed to verify it because we came up with the same answer twice. Now this could be in 2 different variables. This has happened to be all t's, but it doesn't have to be. It could be the same. It could be different variables too. Okay. So the second variety of question has to do with 2 triangles that makes these congruent. And so if you look at the triangles so far, we want to kind of say that DFG and WR are congruent, but we don't actually know that for a fact. We have a bunch of angles in both that are the same, and we have one side length in both that are the same. But for this truly to be true, for this congruency statement to make sense, the side lengths have to be corresponding and congruent as well. Now the steps here, just like I mentioned before, are actually all going to be the same. So we're going to identify the parts that match, we're going to set up equations based on what we know matches, solve using algebra, and then verify our solution at the end. Okay, and so in terms of matching this up, we have this GD, and GD is kind of like the beginning and the end of the congruency statement, so that should match with WR in the second triangle, so those should be matching pieces. The DF is kind of listed first, second, and so that could correspond to WE in the second one, and so we have matching pieces. Now, in terms of setting up these to solve, we do know that GD has to be the same as WR. They're the ones that are matched to be the same, so it's GD and WR. And then we can do a substitution. So GD is actually 6y minus 42, and that has to be the same because congruency and equivalency mean the same thing as the side length on the right, which is -3, and that's a -12 plus y. Okay. So now that we have this set up, we just have to go about the business of solving using algebra. That's our next step. So we identify the corresponding parts. Now we actually have we set up equations. We now have to solve using algebra. So we can do a little simplification here. 6y minus 42. Here we have to do some distribution. So we have a -3 times a -12. That's going to be a positive 36 because 3 times 12 is of course 36. 2 negatives make a positive. And then we have the -3 and the positive y, so we have a -3y. Okay, so now we just go about the business of solving algebra. We need to get all our y's to one side, so let's please first add 3y. Okay, 6y's plus 3y's make 9y's. And then 36, of course, carries because those are going to be canceled to 0. Okay, we should now get y by itself by adding 42. Okay, so it's canceled to 0, bringing down to 9y. Let's see, we have 6 plus 2 is 8. 4 plus 3 is, of course, 7. And so it looks like we're dealing with 9y is equal to 78. So 9 times y we'll get rid of by dividing. Okay, and so we end up with y is the same as 78 over 9, which is an okay way to leave your answer. Now, if that particularly bothers you, you can grab a calculator. Let me grab mine. Okay, and we just take 78 divided by 9, and then we end up with 8.6 repeating. And so that's an okay way to say that too. So 8.6 repeating. Okay. So we had to solve for x as well, but we solved for y pretty successfully, so I'm pretty sure we can use the same basic format. So the x's are defined by df being the same as EW. Let's bring in the values. So we know that 10x plus 8 has to be the same as 4 plus 13x. Okay, now we just go about solving algebraically, which you guys done a ton last year. So let's get all the x's to one side. So let's take the 10x away from both. Okay. So let's cancel to 0, leaving us 8 on the left-hand side. So 4 plus, and then it's 10 minus, or 13 minus 10, and that'll leave us with 3 x's. Okay, so let's evacuate this side by subtracting on 4. So 4 is the same as 3 x's. Okay, so divided by 3, divided by 3. Okay, canceled to 0, or canceled to 1, excuse me. So we have x is equal to 4/3, or that's just going to be 1.3 repeating. Okay. The fact we have some decimals shouldn't freak you out. That's just how it goes, right? And so now it's time to summarize. And so a summary can kind of go two different directions. One, you can just kind of look at all the notes and kind of answer that essential question. How do you prove triangles are congruent without translations, reflections, and rotations? We can recall that reflections, translations, and rotations are rigid transformations, meaning that if you use vectors or perpendicular bisectors to move a shape, we know the shape's not going to change size. Which leads us to an important question, which is, well, what if you don't know that you did a transformation? What do you have to do? With the answer being you have to meet the full definition of congruency, which means you have to look at all the individual angles, individual sides, and make sure they all match up and have a congruent counterpart in each one of the triangles, so they match by pairs. And so the weird skill is being able to note it and mark the triangle. You can't get fooled by that if you're going to do this kind of work. We have to make sure we can write congruency statements where all the pieces are lined up in order, which is really the big thing that beginners have to know. If they're not matched up in order, you're not going to write them properly, and if you're not writing them properly, then the rest of the work is going to kind of go poorly. The big calculation you have to make out of this part of the work is that you have to be able to match up the side lengths and write equations of equivalence, because congruency and equivalency mean the same thing, and then solve it. And so there's some algebra work we have to do as well. Now, if you're having trouble writing summaries, I can offer this as a way to frame a good summary. If you don't know how to write a summary, or maybe you're having trouble, because many people have asked me like how to write better ones, you can answer these 3 questions in your summary. What do your notes answer? Like, what's the big question? And when you talk about like what do they answer, I do mean what's the essential question. What do your notes help you do? Like, what kind of skills, what kind of questions can you answer now that you have these notes in your possession? And then finally, the other thing you can have in your summary, how do these notes connect to other things I know? In other words, how is the information similar to what you've done before? You can take some guesses on how this is going to help you kind of moving forward, right? So I know those notes are really long, but that's how they go sometimes. It's a lot of comprehensive notes. And so you now have 2 levels of work to do now that you have the notes in your possession. Anything not done today, you should take to be homework for Friday, right? I appreciate you guys. Thank you for letting me listening to me talk. Thank you for taking these notes and trying to get better today, right? So everyone have a wonderful day. I'll see you in a couple. Goodbye.